Hi, thanks for joining us. My name is Dan, and I'm with RA Fischer. And today I am joined by Dr. Rolf Eilers, the engineer and really creative, innovative genius behind the developments in the new Fischer technology for iontophoresis and treating hyperhidrosis. And Rolf was kind enough to give us some time today for this interview. And we really wanted to talk to him about some of the technological questions that we get from a lot of patients, really understand what some of their motivating factors were behind innovating and developing the new technology behind the Fischer. And so, Dr. Eilers, thank you very much for joining us.
Yeah, you're welcome. So it's a pleasure for me to give you the right answers.
Yeah, fantastic. And so again, Dr. Eilers is actually coming to us all the way from Germany. So again, wie geht's? That's the extent of the German that I will whip out for right now. And but really, I just wanted to start with the biggest question, at least that I've always had, is what was it about iontophoresis that you saw an opportunity to really innovate, from a technological standpoint?
Yeah, from a technological standpoint, iontophoresis, it's an old-fashioned technique. It's well known even for 30, 40, 50 years. So you can find papers describing it in a quite well way, dated from 68, 69, something like that. The key point was to make it more practical and safe for the user. And that's the key point. Iontophoresis, at the end of the day, it has to be done at home by the user by himself. Just for the beginning, it could be a therapy which it's used in by the doctor or supported and assisted by them. But at the end of the day, it's a home therapy device. It has to be safe, simple, and effective. And that's what we were missing with all the other systems on the market, still missing. And that was the reason why we designed or redesigned the device, which is now called the Fischer device. And there are several aspects in which makes it really safe and easy to use.
Yeah, that's what I was going to bring up because, having personally spoken to hundreds of hyperhidrosis patients throughout the years, when talking to them about iontophoresis at first, especially if it's a very new concept for them and something that they're just kind of stumbling across, when you started talking to them, the idea about metal and electricity and water, it was a hurdle for them to just to overcome. And despite the effectiveness and being able to demonstrate the safety of the treatment, for some patients there was just always a disconnect between that metal and part of the treatment. And so really the biggest innovation that you've brought is with the silicone graphite electrodes with the new Fischer, right? So now you go from those metal plates, you have this soft, it's a flexible material. And so what were some of the things really about the metal technology that you saw that there was room for improvements on?
First of all, metal electrodes are old-fashioned, so to say. I think it's difficult to see any other therapy with metal electrodes there. Metal, it's like a wire, and it's a healthy reaction from a customer to say, oh, I'm cautious between for electricity and metal. And by the way, I need to explain a little bit about iontophoresis, the process behind. Iontophoresis, it's a galvanization process. You have some electricity source, you have voltage, and so there's some process. It's called galvanization. And in fact, what's going on with that? There are ions generated at the interface of the electrode. And so these ions, there's an accumulation during the therapy, and this can end up in an accumulation of these ions, which makes the water or whatever it's around very acidic or very basic. And this attaches the metal, and this could end up in a corrosion of the metal electrodes, and also even in terms of color change, corrosion for aluminum electrodes and the color change in case of these stainless steel electrodes. Stainless steel, anybody believes it's non-corrosive, but it's not sure. It depends on the level of acidity, for example. And so these electrodes are corroding. Furthermore, it's well known that metal electrodes are, let's say, very risky for patients who have allergies in terms of metals. And if you know that galvanization is it's a usual process, for example, for chrome plating of plastics, as you know it for your door handle of your car, it's a deposition of metal ions. So they are released from the electrode or even deposit to the electrode. And so there might be also metal ions in the water. And therefore, it makes lots of sense to eliminate or substitute the metal electrodes by state of the art. And that are silicon graphite electrodes. Graphite by itself, it's an inert material. It's stable, and silicon makes it quite flexible. And this flexibility has another advantage, especially for iontophoresis, if you are using it for the underarms, for the axillaries.
Right.
If you have these small, let me show it to you, these small underarm electrodes made of metal, and you will clamp it under your underarms, you will have several sites which different pressures on that. And in comparison to that, if you have these flexible underarm electrodes, they will follow the curve. And one of the most important points in terms of iontophoresis, safe iontophoresis, is a uniform current density, and you have to prevent any pressure sites on your electrodes so that you have a very uniform current density across the surface. And that makes lots of sense for several reasons. And by the way, the silicon graphite electrodes, they are very stable, no spare parts, they are safe, easy to use, no corrosion, nothing to clean. So that is really state of the art, I would say, and many benefits, especially in terms of iontophoresis.
For sure. I think, our patients can definitely agree, especially talking to a lot of them who have gone years having to worry about refills, prescriptions, sometimes shortages at pharmacies when they no longer carry things. When you can tell them that this is a solution that really is a one-time investment that lasts a lifetime. There really are no replacement costs involved, unlike some of the other metal-based options, right? That will every 3 to 6 months, potentially for some patients, as you mentioned, based on a variety of factors, could be having to call in, order new things, right? And of course, that leads to hiccups in the treatment. And one of the keys to iontophoresis is really trying to maintain the consistency with treatment, right? And so I think that's a really big motivating factor for patients as well. And I'm really glad you brought up, you showed yours. I have mine over here, right? And I know previously, with our underarm attachments in the past with the metal ones, you had, always the exposed metal pieces, right, which could sometimes lead to contact against the skin, or more specifically with those metal plates, right? Because if the design, as you know, with the L shape and it coming up out of the water and the tray during the treatment, an open metal contact point with live electricity feed, never a good idea, right? Because you can have a finger, a toe, something that comes into contact with it for too long, right?
Dan, it's the same principle. It's if you have a direct contact between your skin and the metal, the electricity, what will it do? It will go to the shortest and easiest way. And so all the current is going directly between your finger and the metal. And so you have very high current densities. And the result will be so-called electrical burns on these sides. And therefore, it makes lots of sense, like this with the auxiliary electrodes, as well as for our large electrodes for the water bars. Let's say that there's no metal, no wire, no clamp, nothing. It's completely isolated.
Right.
That makes it really safe.
Yeah, absolutely. And so you talked about current flow. And so I kind of wanted to jump into the discussion of power, because a question we frequently get from patients is, number one, what's the right power level that I should be treating at? And we explain to them that everyone's body is different. But could you explain to us, why there are different power settings throughout the machine, and why someone might have to treat at say 8 milliamperes versus someone else still treating the same area might have to treat at 12 milliamperes?
Interestingly, if you go to literature, they are you will see some figures and numbers around that. So for hands and feet, you will need to use this, and for auxiliaries, we will use that. Based on our experience, it's quite different in several ways. So you called it power. What do you mean by power? You are talking, in fact, you are talking about the voltage and the current. And in between we have the resistance, and it's like a water tap, so to say. Once the voltage, it's the pressure inside the tubing, and the current, it's the water, the level amount of water coming out of that, and the resistance is your throttle and how far it is open. And for the therapy itself, it's a current, which is really the most important one. The voltage is less important. And there's no, in literature, and even based on our experience, there's no threshold of current you need in terms of a certain therapy efficiency or effect on that. And furthermore, anybody is different in terms of this sensitivity. I have learned people, who can really smell electricity. They are treating their feet and smell it with their tongue. And some other people are treating it with the maximum power of 30 milliamp and asking us whether the device is really working because they feel nothing. And there's a lot in between. At the end of the day, one is for sure, for the therapy and the therapy effect, it's a matter of the dose, the electrical dose. Electrical dose, it's the electrical current multiplied by the therapy time or the frequency. So as more often you are using it and more electricity, of course, the higher the dose is at the end of the day. But there's no threshold. Based on our experience, it's really enough to go to a level which you feel still comfortable with.
Right.
There's no level which you have to reach. It shouldn't be harmful for you. And this level, it's very different. And that's the reason why we, in our instructions for use, we do not have any concrete figure. The user himself, he has just to start with 1-2 milliamp, and he has to increase that step by step. And then he feels a slight tingling. Yes, of course. But that's okay. And he has never to go up to a level where it's harmful. It's not necessary. Typically men or people were saying it has to hurt me, otherwise it won't work.
Right, the
And
strongman mentality, right? Well,
that's
if
a
I treated
strong
it
man
this
mentality.
and I saw success, but what if I doubled it? Would I see results faster or more prolonged? And not true. So we do always try to tell patients, and especially if they're it's their first time with iontophoresis, it's okay to start low for your first treatment, really, and then gradually build your way up during that first phase of our treatment schedule. And using the manual and the journal in back to really, document what they were treating at so they can feel comfortable as they get up to a level. But ultimately, from my experience too, most patients do establish kind of a rhythm, right? That baseline where they go, okay, this is about the most I can tolerate comfortably with my hands and my feet, and then they go from there. I'm really glad you brought up the difference between voltage and the milliamperes, right? Because that's constantly questions we get from patients who say, well, I was treating at 20 volts or 12 volts with another machine. Maybe it's a homemade setup, maybe it's just another competitor device, but then they're trying to figure out an equivalent between their experience and what ours is. So we try to talk them through those differences. But for anyone out there maybe with a similar question, high level, and I know you kind of explained with the water analogy, but why is it totally you can't really compare the voltage to the milliamperes as terms of the treatment because they're totally separate things.
Yeah, that's right.
Right.
Totally separate things, and you have to keep in mind, it's you have the voltage as a power source. The current, it's the amount of of water going back to the throttle, and there are certain resistances in between. So it's your body, your skin, it's the water, the electrodes, So it's a sum of all of that together. If I would be in a situation and if I would have different systems in front of me, I'm the best sensor of doing that because it's a tingling of my fingers.
Right.
So if this is the same, it's the same treatment. So because it's the same amount of current going through my fingers or my hands or my feet, and that's you are the best sensor by yourself for
Most
comparing
definitely.
different. Yeah.
So if there's a patient who's maybe struggling with a body resistance issue and the treatment, what are some things that they can try to see effective results still with iontophoresis?
What do you mean then by body resistance? How
So,
are
for
they?
example, with the way that the Fischer is set up, if their resistance is too high, the treatment timer won't start counting down, right? Because the circuit is not complete for the patient. So, for anyone who's maybe experienced this, or maybe their resistance has fluctuated between their hands and their feet, which is something that I've encountered in the past. Is there anything that they can do to change their treatment, that they can add to the treatment to kind of work around that just natural bodily resistance issue?
Okay. Natural body resistance, if you go to a textbook, the textbook will tell you it's about, just to give you a figure, 2000 ohm. So that's the unit for resistance, it's ohm. And but in fact, we have seen situations which where the resistance was up to 10 or 15,000 ohm. For what reason, however? The body resistance, that is something you can't change. It's your body more or
Right.
less. What you can change is, and that's what I said before, you have to take a look to the whole resistance consisting of your body resistance, but also of the skin and also of the water. There might be water which is too soft, so to say, because they're too lack of ions in. But
Right.
typically, normal tap water can be used. It should work. It should always work, so to say.
Yep.
I
And we
think
always tell patients to really check in with us around that 2 week mark if they haven't seen results yet, because a lot of times patients don't know that they have water filtration systems built into their house. And so despite going to the tap, they didn't know that it was actually filtering out those essential minerals that the Fischer needs to deliver the iontophoresis treatment.
if you have a lack of ions, you can add some baking soda. You could even add some salt, but salt will itch you. Salt, it's not really comfortable at the end of the day. But let's say the most risky part or the biggest fault is, if you are using creams for your finger.
Mm.
This will increase the body resistance a lot, and so that makes sometimes problems. So, but as long as you are using normal, um, let's say, things to wash your hands without creams, it will work. And so let's say the Fischer machine, it's designed, let's say, to be capable of getting or working with very high body resistances. There's a level for sure where the system will tell you, no, I'm not working because it's really very, very high. But there has to come together many things, adverse things, which plays together. But typically, the system is really quite working quite well.
Yeah, I definitely can agree with that. And in terms of the water being used in the treatment, warm water, cold water, is there a preference, something that helps maybe with bodily resistance?
Yes, that's our experience, so to say, that warm water, it's always better.
Okay.
It's more comfortable for yourself as a user, and furthermore, it seems to open the pores and to reduce the resistance. So we recommend really to use warm water.
Fantastic. Yeah. So Another thing that we had kind of touched on, and we've been kind of mentioning several times, is that patient experience, the sensation for, maybe patients who are sensitive to the treatment and they're saying, hey, I'm only on 5 milliamperes and it really feels kind of intense for me. What should I do? Is it going to be effective? One of the biggest innovations that you brought with the Fischer is that it's both a direct current and a pulsed current machine in one.
Yeah.
Previously, patients would have to choose between which kind of models, and then there's varying opinions amongst dermatologists. So if you could briefly explain to us, Rolf, what's the difference between direct and pulsed current? Why might someone choose and why might someone choose one over the other?
Typically the old-fashioned technique, it's the direct current. So we have a direct current, constant current from one side to the other side. That's very simple, and that works very well. And if you're going to literature, to clinical studies, it's really the most effective way. And since about 20 years ago, also we see this pulse current. And pulse current means that the direct current is switched on and off in very short circles, so several thousands by a second. And this results in a different awareness of the electricity, a different feeling of that, meaning that the electricity, it's much less. That's at least what you feel. And on the other side, literature and clinical studies tells us also that the efficiency is reduced.
Okay.
And so we recommend, let's say, if you start with iontophoresis, to start with a direct current. Keep it simple. And typically you will have several milliamps, whatever, let's say 7, 8, 10, 15, whatever, just go ahead, because this is the most effective way to see results. And if you're starting with, that's the most important thing, because most people are sitting in front of the iontophoresis device saying, hey, it's just tap water and electricity.
Right.
There's no medium, there's no pharmaceutical inside. How could it work? Even
It's
no
hard
herbs.
first. Yeah, that is one
It's
of
just
this
technical.
really works is a question that I get from a lot of
It
patients.
really
Like,
works,
I'm just finding out about this now, despite it being around for so long. And it's really, you don't have to put anything in the water. And nope, I tell them it's just the tap water from your sink.
It's tap water, and it's time consuming. It's you need to spend time, and you need to have several treatments before you can see certain results on that. And so from our point of view, the most important thing is at the beginning to see first results as soon as possible, to say, oh, it's working, so let's keep going on with that.
Yeah,
Keep the therapy.
absolutely.
And that's the reason why we recommend the direct current. And there might be also cases where the pulse current might be the better choice, especially in cases where you are tolerating only very low currents. And let's assume you're just tolerating 1, 2, 3, 4 milliamp. On the console, on the device, you can just switch between 1, 2, 3, or 4. And even if you go between 3 and 4, it's 1/3 more of current, so it's a big step. And if you are quite sensitive for that, the pulse current might be more practical for you, because then you will go up to 6 or 7 milliamp. And most people think, hey, it's a higher current, so it works better. But most of the people forget that this current only works on a certain portion of the whole time. So it's not working the whole time. And if you would calculate that with the pulse current, it's always less effective than the direct current. Even
Yeah, and what I've really right.
so
Sorry, and what I was going to say is, what I've loved about having that option in one machine is really for situations where patients have some experience with iontophoresis in the past. They'll say, 10 years ago, I tried it in a doctor's office, or I did a homemade setup once upon a time. I didn't like it. It hurt, and and I kind of moved on and looked for another solution. So when they can come back and they can look at this new machine, which is beautifully designed, very simple, elegant, and easy to operate, and then you can talk them through, well, what you experienced last time, we have an option for you to treat to a more comfortable experience while still seeing results. And so it kind of opens the door to the possibility of using iontophoresis again for maybe anyone who has a mental block because of a bad experience in the past. And so that's what I've really liked about that option.
And that's something with iontophoresis. Iontophoresis, it's a therapy where you always need to learn how to treat it in your specific case. I have talked to people, users using it for 20 years, and they are still changing things. And the good thing with iontophoresis, you can't really do things wrong.
Right.
If you think it's time to change things, try it, give it a
Mhm.
choice, and you will see it. You are the best guy to judge whether it works for you or not. And
Yep.
therefore, we said at the beginning of the development of the Fischer, we said, why should we make a marketing story out of that? 2 devices. Let's put it in one device so it's user friendly. The user has the option later days, let's say, just to try it. Might be it's a better way, perhaps not for the initial phase, which is more intensive and you would like to see results, but later days for the maintenance phase.
Yep.
So, and you can just try it.
And those are all things that we talk patients through too over here, right? Because every patient who's referred to us is assigned to a personal treatment specialist who starts from exploring your insurance options to once you get the device. A lot of our patients just give us a call, put us on speakerphone. They say, "Hey, can you walk me through setting this up?" Absolutely. We can walk you through doing your first treatment so you can really see how easy it is. And then from there, we provide technical support. And as you said, we walk them through this 3-phased treatment approach that really works to get them down to having to rely on the device as infrequently as possible. And everyone always asks me, well, when do I know? When should I start this? And really, I tell them, as you said, you are the best gauge. Once you're really starting to see results and you're satisfied with your level of dryness, don't be afraid to start stretching in between treatments. I've had some patients who regularly go 5 to 6 weeks in between sessions. I have others who just like the proactiveness of treating every Sunday, and they tell me, I put on the football game and I treat for 20 minutes, and that's just kind of my routine, and they stick with it. And so that's really where we like to take that personal approach to our patient experience and really know that they have the guides. They have someone that they can rely on to ask questions with, and it's not like you're getting a call center where you have to explain who you are every time. We're always familiar with who you are, and we can kind of jump right into things with you. And so one of the other things I wanted to pick your brain about, Rolf, is I've seen out there, this new variable pulsed current as kind of potentially a third option in iontophoresis. Can you talk to us anything about variable pulsed current and potentially how that differs from direct and pulsed current?
The variable pulse current, it's an additional parameter. As I talked to you, if you have a direct current, it's always a flat curve of,
Mhm.
let's say, 10 milliamp. If you have a pulse current, you have always a rectangular curve going, let's say, from 10 to 0 and up to 10 and all the way around. And you have a pulse rate saying, okay, let's say you have about 50% it's on, 50% it's off. And so it's switching to both sides, about a few thousands per seconds. And with the variable pulse current, you can change that pulse rate. So you can change it from, let's say, 50 to 60, 70, 80, 90, and 100%. And 100% at the end, it's direct current again, of course,
Right.
because then it's a flat curve again. Um, and I know that people claim that this is a very good option, let's say, to optimize your treatment,
Mhm.
and to find the best way of both worlds, so to say. Direct current is very efficient, and the pulse current, it's really very comfortable. Um, at the end of the day, we were talking about that quite intensively.
Mhm.
And to be honest, I couldn't give you an advice how to treat and how to take the right adjustments, because you have an additional parameter. And I think it's not really necessary. It makes things more complicated as they have to be. And that was our message, to keep it as simple as possible, and let's to keep it out. There might be people who are interested into that. There might be people who are, like with many other technical things, who want to play with that. That's fine. But let's say most of the people we have talked to and we know suffering hyperhidrosis, they do not have a technical spleen. They would like to get a solution for their problem. And that's it has to be simple.
Yeah, because especially when you're dealing
that was
younger
the reason why we
too.
decided, let's say, keep it simple. That are the two options they have, and it's quite obvious the difference and how to deal with that, and that's it.
Right. Yeah. So we really try to stick patients on that direct current path and only go to the pulsed current route if they're not seeing results yet, or if we identify other issues, kind of like we talked about. So yeah, when it comes to variable pulsed, not something that we've really found, to be something worth exploring due to the impact that it would make on the treatment. It's kind of just going down the rabbit hole with things. And as you mentioned, the easier that you can make the treatment, the less intimidating that you can make iontophoresis, which I think you've done with the Fischer. We deal with so many younger patients, and from my experience directly, anytime you can make something easier for younger patients, the more likely they are to embrace it, the more likely they are to follow through with it. Again, this is something that they'll be using for the rest of your life, and we have patients with the same device for 20 plus years, so it really is built to last. And with that as part of it, the biggest probably feature that our legacy patients have responded to, and we've actually been back ordered a few times on the new Fischers, simply because the demand from past patients was overwhelming when they saw that you could treat hands and feet at the same time with the device. And so can you talk us through maybe how someone goes about making that transition to treating hands and feet separately, to where maybe they had different milliamperes that they were treating at, their hands versus their feet, to then doing the dual hands and feet at the same time? How do they figure out what power setting or what milliamperes they should start treating at?
First of all, if they are starting their treatment or the therapy, we recommend that they treat hands and feet separately.
Right.
And there's a simple reason for that. As I said before, if you have your hands or feet, you have a specific tolerance in terms of electricity. And in order to be really efficient as soon as possible, you have to go to that trigger level. And hands and feet might have a different acceptance of electricity, so the current might be different.
Right.
And so for the first phase, we recommend to treat them separately. And after a certain while, you can do it in parallel or at once. Let's say putting two hands in one tray and the 2 feet in the other tray. And you can do this in case when the current levels are not much different from each other. Because otherwise, let's assume your hands are, just accept 5 milliamps and your feet would accept 30 milliamp.
Right. Too much of a gap to
yes,
put.
and if you would treat both, what will happen? Your hands will claim and say, hey, 5 milliamps, it's harmful for me. And the feet will say, hey, did you start already?
Right.
And that's the reason. So it has to be in the same level, so to say. And at the end of the day, you can even try it. If you're in maintenance phase, just give it a trial, do it together. And if you see, my hands are not so good more, or my feet, whatever, just decide on that, change it, go back, or go along with that.
Yeah,
It's
I
your,
mean,
it's
just
your
think of
decision.
it, right? Face value, the skin on your hands is just a different thickness than the skin on your feet, right? And so that's one of the reasons why the body may be able to tolerate different settings. And what I
Uh,
find is that when patients are kind of treating maybe at like the 10 to 12 range with their hands, maybe in the 12 to 15 range with their feet, they've been able to find that balance by basically splitting the difference, right? Because it's not too much of a bridge for them to gap.
yeah.
And it's something that generally they'll start to work into their treatment schedule maybe after a couple of weeks. We really do advise that they start treating separately to establish those baselines. And again, we remind them to use the journal in the back of the manual to chart working your way up, right? And so you can really stay consistent with things. And then if you have any questions about when you're ready to transition to doing dual hands and feet at the same time, which, long term is great because you cut your session times in half, give us a call if you have any questions, and we can walk you through that. But overall, Rolf, those were all of the questions that I kind of had, from that I wanted to go over with you, because those are some of the more
Okay.
technical questions that we get from patients. Is there anything else that you can think of maybe that we didn't touch on while I still have you?
I have to think about. No.
Yeah, I'm
No.
sure we could really go down. That's one of the things, and why I always love talking to you with your engineering mind, is really the technology behind this device is incredible. We're only touching on the surface of the silicone graphite, pulsed versus direct, the auto polarity switch, and then again, haven't even touched on the intelligent software built in for anti-shock technology, or any of those things. And so really, I applaud you and your entire team for developing this. We've had patients leaving reviews saying, hey, it is fantastic that this company has invested in the research and development to make an improvement on something that was just stagnant for 30 plus years. And so thank you, for everything that you've done. And we look forward to continuing to work with you and your team.
Yeah, thank you very much. It was a pleasure talking to you and to explaining some technical or engineering background on that. And at the end of the day, it's a quite simple technique. Of course, there are some secrets behind, but to keep things simple and really to help people. So they have to love the therapy. It is part of their life, and whenever they find it useful to use it, you can switch it on, use it without reading the instructions of manual, so it's an easy way to go. And so we are happy working with you. So we are quite experienced on that. And next to the technical aspects, I think there are many advices you can give to customers, and helping them at the end of the day.
Yeah, most definitely. And so I'll continue to compile some technical and engineering questions for you as we get them from patients. And
Yeah.
maybe we can do this again and we can go into some of those software things and some of those other elements behind it. I know there's still so much we have to talk about. We'll do that another time. But that's all I have for you today. Thank you so much, Rolf. And I'll talk to you soon.